And so this is a very powerful technique. And so the idea here is we're going to do an exercise. And the premise of this problem is that we're working with a sequence-based experiment, a qPCR, and we're using a unique molecular identifier, or a UMI. So this is a random sequence that maybe we would use to identify particular molecules in our experiment. So we're generating random sequences here. And the catch is that our experiment, for whatever reason, is utilizing this restriction enzyme, HAE3, which happens to cut the sequence GGCC. And so maybe this is used for another part of the experiment, but in the context of these UMIs, these random sequences, this is a problem because we're not intentionally putting this GGCC sequence here, but there is a random possibility that it can just appear since we're generating these sequences randomly. And so we might want to know what is the, or we might want to know how many sequences do we need to sample in order to encounter 5 cut events, okay? So we're saying here that 5 cut events, or 5 successes in the language of these distributions, 5 cut events is some sort of critical threshold that we want to avoid, and we want to know how many UMIs are you going to have to sample in order to run into 5 of these events. And so let's simulate it using the Monte Carlo method. And the way you can do that is by generating a UMI, generating a random sequence here. So let's say they're 20 nucleotides long. We can use a snippet of code here to pick a random ATCG nucleotide base letter here and assemble a random sequence. And we want to check then, is GGCC there, and perform this trial many, many times to map out this distribution and keep track of cut events, and in particular, when we hit 5 cut events. And so this is the threshold. And so I haven't told you yet, but there is, in fact, an analytical distribution function that describes this exact process. It's not the binomial function. And the idea here is that we're doing this without knowledge of that. So we're using simulation to get around the absence of knowing the exact analytical form. So here's the solution. And so what we have here is the UMI generation script line here from before. So we're generating this random sequence, and it's enclosed inside a while loop. And the while loop is keeping track of the number of cut events or successes. And so we have a critical number here, 5, and the while loop will terminate when we hit 5 successes or 5 cut events. And until then, it's keeping a count of them. So we have an initialized n success here, which starts out as 0, and then it's going through and checking. So we have this conditional statement: if GGCC is in the UMI that we've created, then we up the counter here on our n successes. Go back to the top of the while loop, and we see, we check again, is n successes less than r successes? And if it is, we keep going, keep generating more UMIs, keep checking. And if not, then we break the loop and we append the result, the number of trials it took, the number of UMIs we had to generate. We append that to our growing data file here, this results file or variable. And then at the end, we throw this all into a histogram. So the results is going to be a big list of data, a big list of numbers of trials to hit 5. And we can view then the distribution. So we can see the relationship between the number of trials it takes to hit 5 cut events and the frequency that was observed. So we see a peak here, maybe around 70 trials. If you generate 70 UMIs, more or less, and you have a pretty high chance to encounter a GGCC sequence. But you have a few outliers here, like unusual instances where it takes as many as 200 trials to bump into a GGCC. And you also have these very early ones as well, maybe only 10 UMIs and already you bump into a GGCC, but these are less frequent than, say, the bulk here, this distribution. And we can do the same thing in R. So we have an R version here where we're generating the UMI, again, using a for loop. and keeping track of trials, and we're keeping track of successes. And we're using, again, this while loop to perform this check. So we have this conditional statement here, which is checking if GGCC occurs inside our UMI. And if it does, then we're upping the counter on our successes and going back to the top of the while loop, compiling this results vector here, and then generating a histogram from that data vector.